Good morning, everyone. We have been on the lesson number 6, lines and angles, and exercise 6.3. In that, first three questions been done. Now only three questions are left that we'll be doing today, and we'll wind up this chapter today itself. And from the next lecture to the next video, in fact, I'll come with the new lesson number 12, that is Heron's formula. So without wasting the time, let me share the screen and come to the topic, that is lesson number 6, and till 3, as I said, we did it. Now question number 4, let me zoom it more and take the annotations with the red pen, and let's start with the question number 5. In the figure, if a line PQ and RS intersect at point T, so this is your PQ, this is your RS intersecting at point T, such that PRT makes 40 degree. PRT, this makes 40 degree. Similarly, RPT getting what? 95 degree, and TSQ is giving 75 degree. So TSQ is giving 75 degree. We have to find out SQT. That's enough. Only this single SQT we need to find out. I'll not go with this all solutions. We'll just look after the concept behind finding the angle SQT. SQT means we have to find out this angle. It's very interesting. We can see here. Forget about this STQ now. Just go with the triangle PRT. In PRT, let me change the color so you'll get much more idea. I'm talking about which triangle. PRT. In PRT, we can use the angle sum property in order to find out angle T. So we know that if we add these two angles, 95 plus 40, and summation of this will be 135. If you subtract it from 180, you will get the measure angle T. That has been done here. 95 plus 40 plus PRT equals to 180. 135 plus PTR is equals to 180. PTR is equals to what? 180 minus 135, as I said, will give you 45 degree. So this one is your 45 degree. Now we'll go with the whole figure, and we know that PQ and SR is forming X. Therefore, these two are vertically opposite angles. So angle T will also be 45 degree by vertically opposite angle. So you got STQ as 45 degree. Now we'll forget the above triangle PRT. Will come with the new triangle that is below, that is this one, QST triangle. In this again we have 45 degree and 75 degree. Use angle sum property for the triangle STQ in order to find out the angle Q. So 45 plus 70 plus SQT is equals to 180. The summation of 45 plus 75 will give you 120. That has to be subtracted from 180 in order to get SQT, that is 60 degree. I hope you understand. Understanding. Okay, let's go to the next question. Number 5. I'll annotate and erase everything. In the figure, if PQ perpendicular to PS, PQ is perpendicular to PS, means this is given 90 degree. It is also given PQ is parallel to PS. These two lines are PQ is parallel to RS. Okay. So these two is parallel. So we can say angle X will be equals to angle this by alternate interior angles. Given as QR 28 degree, QRT 65 degree, then find the value of X and Y. So let's start it. How we can find the angle X and Y. First of all, as I said, PQR and QRT, we can say PQR and QRT. These two angles are alternate interior angles. So if we make the total sum of x plus 28 will be equals to what? 65 by alternate interior angles. As they said, your RS and PQ is your parallel lines, and we have considered QRS transversal. Therefore, these two angles are alternate interior angles. So we'll equate these two. So doing so, we'll get the x by bringing this 28 to next hand side. 65 minus 28 will give you 37. So you obtain the angle x as 37 degree. And as I said, this is 37 and we have this is 90. So if we add these two angles in the triangle PQS, in this triangle, if we add 37 plus 90, we together give 127. And using angle sum property for this triangle, if we subtract it from 180, we'll get what? 53 degree. That is your angle Y. I hope you students are getting this. Let's go with the next question. I have to bring it down. In the figure, the side in the figure, the side QR of triangle PQR is produced to point S. So here in triangle PQR, the QR side is produced till S. The bisector of PQR, this is the bisector, and the PRS meet at point T. PRS, this is another bisector which meet at point T. Then we have to prove that QTR means this angle is half of the angle QPR. Means suppose it is said that QTR is half. If this is 60, then this would be 30. That we have to prove it. Let's start. I have erased everything. And since in this figure, when we look at carefully, we find applying of exterior angle property in the figure. Let's see how. If I talk about the PRS, P, R and S, then this angle and this angle are equal to the exterior angle. As we know, the property of exterior angle is what? It is always equals to sum of interior two opposite angles. It is always equal to the sum of interior opposite angles. So PRS they have mentioned as QPR and PQR. PQR plus QPR. One time we have shown this angle, and another time we have shown this angle. Now we have multiplied half with all of them to this equation. On doing so, we know that half of PRS, if we make it half of this, we can write it as TRS. So in place of half of PRS, we will write TRS. And we copied this one as it is. And again, half of PQR, the half of this will be what? TQR. That I have mentioned. So this is your first equation. Now we'll go with the TRS as an exterior angle. TRS exterior angle. For this we have to represent this angle interior to opposite angle and as well as this one. So TRS is equals to QTR plus TQR. TQR and QTR, two angles we have added. This is the second equation. Now In both the equation, you will find here is TRS and here is also TRS. So we'll equate both the TRS. So this TRS I have written here, half of QPR plus TQR. And for the second equation, TRS is what? QTR plus TQR. In both, we have cancelled TQR because both are exactly same on either side of equal to sign. So we left with the QTR is equals to half of QPR. I hope you all understood this. It just needs a practice for the same. These questions at least need 3-4 times practice to remember, and it is the most important and favorite questions for the teacher, those who are teaching in the ninth standard. And probably each and every year the teachers try to give this type of questions, improve that. It's very interesting because it being the part of the property of exterior angle, and it's very in fact interesting. So better you go through this practice well, and we you hope this type of question could come to for your exams. Thank you, and we'll come and with the new video with the Heron's formula. Stay safe, stay good. Thank you once again.